Okay. So last one lecture, I think, not two, we started with this processor architecture. Okay. And what is this processor architecture? Now, when when we will go to discuss with any processor, their internal structure, their internal connectivity, their wire connection, their bus connectivity, all the details, or how the registers are positioned, how the address parts are uh, combined with the data part, all these things, then we should know this processor architecture. Okay, and we started with this 8086 because 8086 was the 16-bit processor was used, and it was started on around 70s decade. Okay, 1970s time, I think on 1972, around 78 in this range. And then we found that when we starting this discussion, that processor architecture, we found that main processor architecture was divided into two parts. One was the bus interface unit, another was the execution unit, right? So as this diagram is showing, and we also observed that your address part, address generation part, and in this pin diagram, it was actually kept for your self-study mode, but that particular thing I show that in pin diagram, we saw that AD1 to AD20, that means 20 pins were preserved for the address generation part, right? Now it was a problem that you are using one 16-bit processor, but you are going to use one 20-bit address generator. So how you will manage it? So that part we will also discuss. That we also discussed at that time that this address 16-bit will be kept for this regular address part, and the 4-bit, the extra 4-bit, that means the 4-bit from most significant site, that 4-bit will be used to select the bit. That is the pattern, like S0, S1, S2, S3, that 4, and the 16 was kept for address. So 16 plus 4, 20, right? And that 4 was actually used by this address generator, like on which time which of the address part will work. And also it was being observed that whenever you are using this address generation part, so just like for S0 there will be 16 address, for S1 there will be another 16 address. So that means for select bit you are using 16 address bit you are using, so that means as a whole you are accessing 20-bit address. So that was the part. And also he checked that the data bus, that is a 16-bit, there was different segment of data bus, like code segment, data segments, stack segment, and extra segment. Okay, so we also observed that whenever you will start anything, code segment, from the code segment your coding will be start, then it will show you that on which of the part, or which of the part of your coding will be executed first. Then it will be followed by the data segment, so which of the data you will access. Then the stack segment, if you are accessing some stack, then which of the stack segment register will activated. Extra segment was also just like whenever you are handling so much amount of data, then gradually the latter amount of data how will be accessed. So all of this thing was there. And one common thing we observed for this extra, for this all segment registers, that each and every segment, how they are accessing this address generator, that thing was specifically mentioned, right? So that was the four 16-bit segment registers. So code segment was, we observed that at a time a certain range of space you can access with this code segment, right? So that is the part, like 64 KB segment was shown here. That can be also one question, that if your total memory is 1 megabyte of size, and you are being informed that you can use a 64 kilobyte of segment, then, and at a time if 4 segment you can use, then how many duration you will require, or how many unit of time you will require to cover the whole memory segment. So simply you will just divide, right? You will divide this whole 1 megabyte with 16 kilobyte, 64 kilobyte. Then you will take 464 kilobyte at a time. So how many segment they are using? Now that thing will be mentioned, that whether they are overlapping or non-overlapping, and parallel. Based on this, you can calculate your thing. So if you don't understand properly, just what the example I have given you right now, I can make a small diagram or make a small example here in fact. So what is happening? It is not working. Oh, sorry, I have kept it. I think yes, I kept it wrong side. Okay, so this was the discussion of code segment, right? So I am asking the question like you are using a 1 megabyte of memory. The same question has been given, and each and every segment has been divided into 64 kilobyte, right? Now your question may be that if you want to access this whole amount of memory, and if one segment, or you can say that if one segment can take say x unit of time, x unit of time, okay, and your all the segments can be accessed with fully overlapped condition, this one, okay. So all the segment can be accessed with fully overlapped condition, okay, and that is also one more point that you can use at a time 4 segment. So question can be like this, that how many duration of time or how many time you need to access the whole memory. Understood? So that means at that time what you will do, you will simply divide this 1 MB by 64 kilobyte. So 1 MB by 64 kilobyte will give you how many segments, right? It is actually segment number. So it is basically 1024 by 64. Both is kilobyte. So 16 segment. You are using 4 segment at a time, right? So how many times you need minimum, how many time you need, 4 amount of time you need, 4 unit of time. Now 1 unit of time is requiring x unit, that means total duration will be required 4x unit. So this type of small question can also be given from this diagram part. Okay, if you don't understand properly, I make a clear one, and that thing also you can see. So here what you will do, my question is first point, you are using a fully overlapped code segments, right? This condition has been given. You have been given total memory space, that is 1 megabyte. You have been also given that your one segment size can be maximum 64 kilobyte. This is segment size. Okay. You are also given that at a time you can access maximum 4 segment at a time, right? So all these 4 condition has been given. So that means if you draw the diagram, so that means how you are accessing those, like this format, you are accessing 1 2 3 4. So these 4 segment you are accessing at a time. True. That means if anyone is asking you that how many segment you can use, so minimum number of segments, minimum number of segment, okay, that will be your 1 megabyte divided by what, 64. You can directly write this 64 into 4. Okay, it is actually kilobyte, so you can change it 1024 divided by 64 into 4. So this answer will be how many? It is 16 by 4, that means total 4. So maximum 4 number of this type of chunk actually I am talking about. So this type of 4 chunk will be there. Now one segment is being accessed with X unit of duration. You are using fully overlapped. So the same time will be required, right? So total time will be required as four X. Understood? So I have this type of small question if given, you can answer. If any problem, you can tell me, I can repeat. Okay. So after this discussion, you can again tell me, I can again repeat, no problem. So this was the part of code segment, right? So then we observed that what is there in this code segment register or how they actually. So then we observed that 20 segment logically 20 segment address is accessed by logically shifting to the left. So why they are shifting to the left? They are gradually moving from lower significant to the higher significant bit. That is the point. Okay. And that is the way that how they are using this 20 bit register. This diagram I was showing you on the previous day, right? And next it was the data segment register. So data segment register, there was basically two part, like source index, destination index. So source index means from where you are accessing this data, destination index where you will store this data, so all these things. And then it was a stack segment register. So here you observe that push and pop two more thing, and parallelly with this stack segment register and this base pointer will help you to access this 20-bit physical stack address. Okay, and someone was extra, that is extra segment register. String instruction use this extra segment data segment to determine the 20-bit physical address of the destination. So all these four were the segment registers, and then we observed what was our instruction pointer. It is just similar with your program counter, that when you are accessing any instruction, will be your next instruction to be execute. So that address will be pointed by this instruction pointer. Okay, so that was the task of instruction pointer. And then we observed that instruction queue. I gave you the example of pipeline, that how you can access this instruction queue with a pipeline, that you will divide your work in accordance to different modules, and then according to different modules you will divide your works. That first this person will do this module, then second person will do this module, like this way it will be transferred one by one, like this. Okay, so this instruction queue was actually passing these instructions from this bus interface unit to the execution unit. Okay, and now our task is coming, that what is your execution unit is actually doing. So now onward we will discuss this part, this execution unit. Okay, so this side is your execution unit, and here you will see that some internal control system is there, flag register is there, ALU is there, temporary registers is there, and some general purpose registers are there. Okay, so general purpose registers like AX, BX, CX, DX, we will discuss in detail that what is this DX. So just before going to all this discussion, you can just make a look in this diagram that every general purpose register like AX, BX, CX, and DX has been divided into two parts, like AH, AL, BH, BL, CH, CL, DH, DL. So this H for higher, L for lower. That means if you are using a 16-bit accumulator register AX, so that will be divided into 8-bit higher number of bits, 8-bit lower number of bits. Okay, same base register if you are using, then that is also will be divided into higher number of bits, lower number of bits. So that the thing will be repeated for every general purpose registers. Okay, then these are actually the source source pointer, base point, stack pointer, base pointer, and then destination index and source index. Okay, so all these things actually are related with these segments. How they are related, that thing will be discussed. Then if you can see some more part, like how they are connected actually, so you can see that this control bus was actually accessing these datas or instructions from this bus interface unit, and they are passing it to this internal control system. Then internal control system is checking that what type of instruction you are passing, or what type of instructions are being passed by this bus interface unit or this instruction queue, and depending on that it will pass it to the execution unit, that what type of execution is actually required, whether some temporary registers will be required, or whether some arithmetic logical unit is required, or whether some flag register is required, like this. So we can take one small example. How? Think that when we were discussing this last week lab, actually. So in last week lab, there was one question, I think the third question, right? In the third question, there was the discussion like b plus c minus d, then a equals to a plus 5, then again e equals to a multiplied by 3, something like this type of calculations were being performed, right? And what we are taking the variables, or where we are storing these variables, we were storing these variables into t registers, right? So why we were storing these variables into t registers? Because we know that once you are fixing one data as b equals to something, let's say 7, c equals to something, let's say 8, d equals to say 9. So these values are actually not being used in intermediate stage. So you can simply delete those data as intermediate situation, or you actually don't need to store them. In whenever you are executing the functions in between the function call, or if you are transferring from one function to another function, you actually don't need to store them. They are only one time using data, one time use data. Okay, so they can be easily removed, they can be easily updated, no problem. So that is why you are using them in the temporary register. What type of temporary register? If you open this merge simulator again, you will observe that these were there for temporary, whose values are not to stored during the function call. And s was also temporary, but their values are saved during this function call. So depending on your requirement, you can select whether you will use this t or s. So just same that whenever your control system is observing that your bcd's values are not being required to store, so that is why you are taking this temporary register, and as you have taken the temporary registers, corresponding data it is fetching, and it is passing to this section from here to here. Then in temporary register, once BCDR is there, I am talking about our previous lab example, question number 3. So BCD all are is there in the name of T0, T1, T2, right? Then they are taking the data from this data bus, right? And you can see all of these things are connected with this instruction pointer. What is the requirement? Once you have not started, your first instruction pointer will point to that particular instruction, b plus c minus d. Once you are executing b plus c minus d, it will point to the next instruction. That was, I think, a equals to a plus 5. Once you are executing a equals to a plus 5, it will point to the next one. I think e equals to a multiplied by 3, like this, right? So you can think that those data are not used second time. That is why they are being used as T registers. Okay, so through this ALU database, those data are being passed to BCD, and then through these temporary registers, those data are being passed to this ALU. This part. So in ALU, actually calculations are being performed. Whether you are performing any arithmetic operation, or you are performing a logical operation, or anything like this. Okay, so that thing will be performed in this ALU. And then after the performance of this ALU, it will be again passed to this next one. It may be passed to the flag register depending on your code. It may be passed for this destination register to show it to the user, or to represent to the user, depending on your code, that what you have written. Okay, so you can just think that how these connections are being made. So this part is okay. You have now seen that how your bus execution unit is connected with your execution unit, and how your temporary registers, internal control systems, flag registers are being connected with this ALU, and how the ALU calculation is being done. All thing is okay, no problem. Right, and even this ALU databus, how the data are being passed to this temporary register, you can see that this databus is connected with this temporary register with a bidirectional connection. So that means once you have performed or once you have done this operation, this result also can be, you can store through this database, right? To show the results to the user like this. So this part is okay. So now what is pending? These registers are pending. That what are the tasks of these registers? So later, let us read something that what has been written in this slide actually, that EU decodes and execute instructions. So just name suggest. Always I used to say this word, that whenever you don't know anything, just read, in case of microprocessor computer architecture, the name properly. Read the name properly, only you will have your answer. Now you have to just make the answer little bit of logically. Just like if I ask you that what is the task of execution unit, if you say that execution unit only executes, that is also true, I understand, but it is also representing that you are not understanding. You are not understanding, right? So that means how you will execute, or how your execution unit will execute. It will first fetch instruction, right? Then it will decode, then it will execute. So if you say these 3 points back to back, that means you know. And if you think that you don't need to remember anything to say this thing, right? So say I am saying you anything like any example, you can say that something like any type of instructions. If I ask you that tell me your name, right? So the same thing, just like I gave you in the first day of lab, that I am Bengali. If I ask you that tomar naam bolo, that is a Bengali sentence I just told. So those students who know Bengali, they can easily say this thing. But those who don't know Bengali, they will first try to decode this instruction, that what sir said. Now, once they will understand that is not the language they know, it is not possible to them. They cannot decode this instruction, they cannot execute this instruction. But when I will say that, please tell me your name, that particular English language known by everyone, so every student can decode this language, then every student can give me the answer. Right? So every execution unit have some steps. Understood? First it will fetch. That means you just listening what I'm saying, that is the fetch. Then you are decoding. That means if you know the language, common language, if I say, then if your brain can easily decode that yes, he is asking the name. Okay. And then you will answer. Yes, my name is this. These are the steps of execution unit. So this thing has been written here. Okay. So this thing actually you will see lot of time in coming days. That instruction fetching steps, that what are the phases of execution of the instruction. You will say just like similar way, that you will fetch the instruction, you will decode the instruction, you will execute the instruction. Now in between of these steps, some other steps will be included sometimes, right? Just like someone write like fetch and decode in two separate steps, someone keep fetch and decode in one single step. So that is actually some separate issue, but basic part is same. Okay, now the next one is 16-bit ALU for performing arithmetic and logical operation. This one. This one. What is this one? This ALU. So what is the function of this thing? Again the name ALU, arithmetic logical unit. So arithmetic logical unit, that means those unit who is performing this your arithmetic or logical operation. Basically your system is actually doing this thing every time, arithmetic and logical operation. Right? Then we are coming to the section of 4 general purpose registers. Okay. So where are the 4 general purpose registers? This AX, BX, CX, DX are 4 general purpose registers who are basically divided into 2 parts: AH, AL, BH, BL, CH, CL, and DH, DL for the higher order data and lower order data. These 2 parts. Okay. Then the pointer register. So these two are the pointer registers, stack pointer, base pointer. Okay, and the final one, that means the last one, DI and SI are the index registers, source index and destination index. We have got this name earlier, this source index, destination index, where in this data segment register part. This part was also related to the source index as destination index. So obviously when you are performing some operation, you need the data. Data segment will be related with this destination source index. And when you will store the data, or you will save the data, or you will show the data to the user, at that time your source registers will be used as the, sorry, your destination index will be used by your data segment registers. Okay, so those are the parts, and here the same thing has been said, what I just told, that who will be divided into which segments. Okay, so now if we move to the next part, that EU registers. So EU means again the same thing, execution unit registers. So what are the registers are there in this execution unit? So the first thing we would like to say, that is the accumulator. So till now almost 3 lab you have done, and you know the basic structure of this MIPS programming. So I hope that everyone is quite familiar with this term accumulator, right? Because different time we have seen this thing in addressing mode, also different time we have seen this thing accumulator, right? So what is the accumulator? In this case we can see that consists of two 8-bit registers AL and AH, which can be combined together, use a 16-bit register AX. AL in case contain the, again the same thing, actually no extra or no new thing they are saying, what already we have discussed till now from the beginning of this class, that AL for lower, H for higher. So AL will hold the lower order bits, H will hold the higher order bits. Okay, and then IO instructions use the AX or AL for input output. So whenever you are giving this data as a 16-bit data, so you will use the whole register. That means you are using the 16-bit data. So all AX registers you will require. Now, if you use any 8-bit data, right? So at that time, your AL registers will be active. So now think you are using a 64-bit system, right? Your laptop is 64-bit laptop. My laptop is also 64-bit laptop. So that means they can handle the word length of 64-bit. My system's accumulator can handle 64-bit data. Now, when we are using this smart simulator, the simulator is actually handling how much amount of data? There were 8 hexadecimal digit. So that means simulator is handling 32-bit data, right? So once you are using this 32-bit data in this 64-bit system, which of the part will use? This AL part. That means the lower order bits of the accumulator will be sufficient to handle this 32-bit data. So my higher order bits are not being used. So they are actually resting, right? So that is why it is being suggested that once you are using this 64-bit system, use 64-bit of softwares, because at that time your whole system can be work with its full strength. Or if you are using with 32-bit data, 32-bit software, that means half of your system is not being utilized properly. Understood? That is the point. That why, if you have this 64-bit system and you are using, you would like to use basically these 64-bit softwares. That is the point. Okay, so these are the accumulator registers, and you can use this multiplication and division instructions. Also use this AX or AL. So why this thing has been written here? We have already used this part in the last example, that when you are using this division part, right, or when you are performing this odd even part, this HI LO. So HI for the higher order address bit, LO for the lower order address bit, like this. Okay. So now let us check the next one. That is a base register. So consists of two registers. Again, the BLBH, the same case, same scene. This is BL is the case contains lower order byte of the word, higher order byte of the word, the same thing. Then the general purpose register whose contents can be used for addressing the 8086 memory. So if anyone is asking that what is the function of this base register, only one point is sufficient. So here maybe four points has been written, but you need only one. Which one? Third one. Which is the purpose of this base register? The base registers contents can be used for addressing the 8086 memory. So again, if you think that difference between accumulator and base registers. Accumulator, that means it is actually for performing any operations, for calculation in the register when you are being performed some, is being asked to perform some operations. So your accumulator is being activated. Now base registers. So as name suggests, again base, that means from where you are actually starting, base. So base register address is for addressing the 8086 memory. From where you are starting, then that is your first address. Then once you will access the other part, depending on the instructions, what the instructions are being used, you can easily calculate the next address or the resultant address or the other thing, right? So next one is all memory references utilizing this register content for addressing use data segment as the default segment registers. So where we got this term DS, data segment register, we observed in the bus interface unit, right? DS, data segment. So that means those who are basically using this base register, they are actually utilizing this register content for addressing the use of data segment as the default segment register. So that means you are starting any operation, you are in any location of your whole memory address. First thing what you will do, you need to perform some operation like maybe addition, subtraction, multiplication. So with which you will perform this data, with the data actually. Or just like example, if I say that once we are being instructed that we have to report in university, we have to report in university for some because for our day-to-day activities now should be done from the university. So first we are informed that we have to report only for 2 days. So my reporting time is Monday and Tuesday. Okay. So I will report, I know. But from where I will operate? I will come in university. I cannot sit in the ground for taking your class, for taking your lecture. Okay. Because it may be good that in ground winter time it is very, most of the students are running in the ground in the winter time, but in the summer time or in the rainy season you cannot sit after long hour on this ground, right? That means first I need to know that what is my sitting place or where is my sitting place. So that is the base register content. So base register will tell me that from this particular address you will operate. So that means from this particular room you will sit, or from this particular cabin you will sit. So once I have sit in this place, then I can start my work. So what is my work then? My work is obviously taking your classes, taking your lectures, okay, from the time to time. So then what I am accessing for the relevant documents or the for relevant systems, that means to take your class, first I have to take my laptop right now. Or if I took this class in offline mode, then what I should do? I will first check that in which room my lecture has been scheduled. So I have to move to that room. So that data will be stored in the data segment register. So I will check in the data segment register that what is my lecture room's room number, maybe CH101. So I will move to CH101 for taking your class. And from that particular room, I will take your class. Okay, so that is the concept of base register and how they are connected with the data segment part. So all the memory references utilizing this base register content for addressing use data segment as the default segment registers. So if any default segment register has not been specified, it will be by default, the data will be stored for it in the data segment register. Okay, so that was the task of base register, and then counter register. So counter is for again the same thing as name suggests, right? So counter means you can easily know that counter when you will count like 1, 2, 3, 4. So some concept of loop, some concept of rotation, some concept of shifting from here to there, that type of thing. We have already done. We have already designed some set of counters, right? In the Logisim also we have designed. in the previous same also we have designed different types of counters. So every time we have seen that just like any pattern is being repeated, or you are just counting to upward direction like 0, 1, 2, 3, 4, 5, or downward direction 10, 9, 8, 7 like this. So whenever you are trying for the shift, rotate or loop, then your counter register will be used. Okay, and other thing is same. Again here also your counter register CX will be divided into CL and CH. So once you are trying to access some lower order data, you will use CL part. Once you will want to use the full data, then you will use the CX part like this. Okay. So some example has been given that the counter registers example that whenever your loop will be started, automatically decrement CX by 1 without affecting the flags. So what is this? Just like think that you are using some counter. So one unit task has been done. So obviously your counter count will be decreased by 1 because somewhere or somehow it has to be stopped sometime execution, then only you can get your result. If the counter is executed for infinite duration of time, you will not get your result like this. Last one was the data register. So data register is for again the same thing like create 2 bits of data DL and DH. Okay, so just like lower order data, higher order data. So used to hold high 16-bit result in a 16 into 16 multiplication, high 16-bit dividend data before a 32-byte division. So these things are like this HI and LO register, that when you are using division operation, your remainder will be stored in another register, your quotient will be stored in another register. If you are using multiplication operation, your first that means the most significant 16-bit will be stored in HI part, least significant 16-bit will be stored in LO part. So those are the data registers segments. Okay, you have used this in the assembly in MIPS also. Then the next is stack pointer and base pointer. So stack pointer, base pointer, as you observe that whenever you are using the stack segment register, obviously your stack pointer will be activated. Whenever you are using this data segment, already we have seen this, that base pointer or base register, what was for the same thing. Okay, and if I just go have a quick look on the source index, destination index, so this thing we have discussed in case of data segment part. You can see again, at that time we were dividing this segment register into source index and destination index. So source index for this from where you are fetching this data, destination index is where you are storing this data like this. Okay, and the last one is here for this flags. So what are these flags? So these 8086 microprocessor is used to store different kinds of flags. Okay, like sign flag, zero flag, auxiliary carry flag, parity flag, carry flag, overflow flag. So what are the task of these? So much number of flags are there. What are the task of them? What are the task of them? Or maybe like error flag, interrupt flag. So different types of flags are there. Any idea? Little bit of idea why we should use this type of flag, or why our microprocessor is used this type of flag. Say you are using some program, okay, or you are performing some operation like multiplication, or you are using some machine learning algorithm. You are executing some big machine learning algorithm. Okay, and you are handling so much amount of data within your laptop. Now your laptop is not so much strong or so much GPU enabled laptop. It is a normal CPU laptop, and you are trying to train a huge amount of data. So what will be happened? Either it can be done in normal way, no problem, if it can be able to run that much amount of data. But if not possible by it, or if it's not able to run in so much amount of data, what you will show, or what your system will show to you? Out of memory, or memory. Anything?
Overflow?
Yes, right. That is the point actually. That you will see this kind of information like overflow error, or memory management, different kinds of memory related error you can face. Sometimes it may show that fatal error, memory cannot hold this kind of data. So different kinds of error we used to see when we try to train larger amount of data. So actually from where this information is being passed, there is actually one flag register, different kinds of flag register. So just like what the example you told me right now, overflow occurred, very much true and very good answer. Your overflow flag will be activated at that time. Okay, so 0 to 15, total space is 16. So again, in your architecture, one register will hold all these flags, all the 16 flags. Now when this kind of error is being happened, that particular flag will be activated. Just like your system is not able to handle so much amount of data, your overflow flag will be just raise your hand. Overflow flag has answered like this, that yes, I am active. That means your system cannot handle this so much amount of data. So it will throw you one error. So just like in the previous sim, we observed that even parity, odd parity. So maybe your even parity, odd parity means again some checking error kind of checking, that whether it is a even parity thing or at odd parity thing. So if there is even number of 1, so maybe it will raise his hand, or odd parity, it will not raise his hand. That means perfectly working. Interrupt flag is there. In pin diagram, you observe that different kinds of interrupt signals were there. So if you need to interrupt any process or suddenly stop any process, so that interrupt process will be activated, just like this. Okay, so different types of flags are there who are associated with your microprocessor, and each and every flag has some specific task. These are very important, all these flags. Okay, now no need to remember them. Again, I am saying just read and try to feel your program, that when you are performing any programs or when you are doing any operations in your system, each and everything has been faced by you any or any time. You are only just now second year, so only 3 semester only just 2 semester has been covered. Okay, you know a little bit amount of subjects, that is perfect, but within this much amount of programming you have already faced all these flag. You have done Python programming, you have done Java programming. If you feel that what kinds of program you have done in every program or in so much programs you have done, you have faced already all these flags. Sometimes if you feel this digital design part, also you will get some extra flag type of work. Okay, so these are the overall architecture part of this 8086. In the last slide, there is some registers and their task in one line has been informed. So you can read it. But I will suggest that every time, whenever you are reading, just feel that what the task you have done already through your programming part, or whenever you are going to execute any program, then if you feel that you can relate that every time this thing is related with this task, this thing is related with this task, so it will be very easier. And sometimes just relate your own work. That means you are moving, you are going, and think that your system or your brain is a processor. Okay, and also you can relate with them, because human brain is also nothing but a processor. We are getting instructions just now, just right now. What happened? I am taking your class, suddenly some person has come here and they may ask me something. Okay, I just make an just an eye contact with him and I just say that yes, I am coming right now, I am in a class. That means his brain is taking my instruction, that yes, he is now taking the class, so I will come later, or he will come to me later. So that means his brain is processing my, वो इशारों को समझ रहा है, इस टाइप का बात हो गया. ठीक है. So every time you can relate with this thing, it will be much easier. So don't go with this flow and I will read everything, I will just read so much amount of study you have to do. Don't feel this. Just read your what is happening in front of you. You will very much relate with this course. Okay, so sorry for this. I have taken a little bit of extra time today. So sorry for this. You can log out as according to your wish. I have completed today.